Hi students. So welcome to an interesting observation that we have that I made during the conduction of the experiment. While doing this non-inverting amplifier and trying to find the frequency response for different gains, of course we kept input. Of course we calculated what is output maximum, and we found out what is the maximum input that we can apply so that we can able to get an undistorted waveform. And we actually applied this much amplitude, and we were getting different amplification here. And then we could able to find what is the gain in time response. It was almost matching with this one. And we also found what is the frequency response. We've identified the gain in dBs, and we could also find the bandwidth. And when we actually found out gain bandwidth product, it was not fairly constant. It was not fairly constant. So I was just repeating the same experiment, and then trying to understand why it is not same. Is it actually the quality of the op-amp that matters, so and so. There was a very interesting observation. I made a similar observation by conducting the experiment with a constant input voltage which is fairly very less. So I just kept the input amplitude as hardly 50 millivolt. Okay, when the input amplitude is less, so there is no harm that output will going to have a clipping, because maybe even for the last one, even for the last reading also, for a gain of 51, we need to have minimum less than 55. So that's why I selected 50 millivolts. So this will cater for all the gains from 1 to 51. So when I just of course gain from of course this is 1 kilowatt, this from gain from 2 to 51. So this is what the observation I have made. The input was not kept too much. So when the input is kept at 50 millivolt, I started with the value of RF. Of course, the value of RF here is, of course, so since R1 is equal to 1K, so this was 1K, this was 5K, and this was 10K here, and this was 22K, and this was 50K. For these values of RF, we were getting gains as, of course, these are theoretical gains, and these are the gains that were what I obtained. You can see the bandwidth. So this is the bandwidth, how it is varied. If you actually find out the gain bandwidth product, you can see this is 660, 604, 615, 650, and 770. So this is fairly remaining constant. This is fairly remaining constant, irrespective, of course, irrespective of the gain. But it is not so in the previous case where we actually had large input amplitude. So now why this happens is because when the input is more, when you have the output has to swing from very large amplitude and it has to go down. So the op-amps will actually take more time to operate at that amplitude. So that's why if the amplitude is less, the bandwidth of the system or the circuit will be more and more. So that's why you can see, if you can see this. So here you had a bandwidth of, for a gain of 2, you had a bandwidth of, this is fine. You just had a look at this. So for a gain of 6, you had a bandwidth of 60.32 kilohertz. For a gain of 6, now you're getting a gain of, a bandwidth of 106 kilohertz. So where is 60, where is 106? And you just see for a gain of 11, I had a bandwidth of 50. 8 kilohertz, this was 52, and here you can see this was a bandwidth of 27 kilohertz. I'm having it as 30. So here it is fine, especially for lesser gains. For lesser gains, if the amplitude is more, it takes longer. So the frequency is limited at lower gains. So that's why you operate at lower input signal so that your bandwidth will be better. You can see these readings, so you can discard and you can put these values, so then you can see the bandwidth almost remains the constant. So sorry, the gain bandwidth product remains. This is actually GBW. So as you're increasing the gain, the bandwidth is reducing by almost equal amount. So as you increase the gain by x time, the bandwidth will reduce by same x time, so that the product GBW remains the same. So that is observed with an amplitude less here. You can see I have kept it as, so this was 10 millivolt, which is okay. It was not actually 50, it is even lesser. So of course, even if I can keep 50 millivolt, so that is fine. So for 50 millivolt, of course, all these readings what I've taken, it's for 50 millivolt. It's for 50 millivolt, which will cater for all gains. So while doing the experiment, especially while doing the frequency response, keep the amplitude small so that you'll have a larger bandwidth. You can experiment it out. Maybe here also you can see, let me have a gain of hardly 2. Now let me have this 50 millivolt and then run once. So let me find what is, this is 5.221 is the gain. Let me see what is the bandwidth. Bandwidth has gone up to, okay, let me go till here. So what is the bandwidth? This is the bandwidth. This is -3 somewhere here. This is gain. So you can see it is around 371 kilohertz. So this is a bandwidth. So now I will not change the gain. Let me simply change the amplitude to around, because since the gain is hardly what is the gain now? Now the gain is actually 2. So now even if I make this amplitude as 1 volt, let us see what happens to the bandwidth. So if I run this, earlier the bandwidth was 371 kilohertz. Now the bandwidth drastically reduced. You can stop now. See now, from 371. So I'm not changing the gain here. I'm changing the amplitude. Amplitude also matters for my bandwidth. So now you can see. So now it is -3. I had to go to -3. See now the bandwidth is 63 kilohertz. So where is so we had 341 kilohertz. Now the bandwidth is 63 kilohertz. So there is a huge change. This is with the input of 50 millivolt. This is with an input of 1 volt. So this is what the observation is. For a gain of AV equal to 2 with input amplitude 30 millivolt, of course for gain there is no problem, but the bandwidth is good for lesser amplitude than for higher amplitude at the input, because the op-amps will actually take more time to swing from a larger amplitude. So when the amplitude is less, it swings faster, so that it can operate even at high frequencies. Even it can operate at bit higher frequencies when the amplitude is less. So the bandwidth is more if the Vin is less. Vin is less for the same gain. That's an interesting observation. So while conducting the experiment, especially for lesser gains, keep the amplitude less while performing the frequency response. First, time response. So what are all these things? These are all maximum amplitudes. So maximum input that you can keep. So even if you keep 10 millivolt, 50 millivolt here, nobody will object. Instead of 1, I can give 50 millivolt. Instead of 2, I can give 50 millivolts. Even then, the time response also gets verified. So these are all just the maximum amplitudes. We kept less than that. For getting a proper gain bandwidth product, if I keep the lesser amplitude, I'll get larger bandwidth. So that is the only major observation that we have made. So while conducting the experiment, so this you can experiment it out. Thank you.